Okay, upthrust and floatation. So first of all, what is upthrust? Well, upthrust is equal to the weight of the fluid displaced. What on earth does that mean? Okay, so let's do a little experiment to explain what it means. You've got a bowl of water and you've got a Newton-meter, and on that Newton-meter you've got a rock, okay, and you put that rock in the water, and what happens is that when you lower that rock into the water, well, two things that you'll notice happening. First thing you'll notice happen is that the water level will go up and the Newton-meter reading will go down, and the water will go up by exactly the same amount, so that volume will be the same as that volume. So the volume of the rock that you've put into here will be the same as the volume that the water increased by, because what you've done is you've pushed that water out of the way, and that's what displace means. So this square here will be the same area. So it's not in my picture, this red one's clearly bigger, but let's make the green one bigger just to make up for that. Okay, so this green block has the same volume as this red block. Okay, because as you push it down, the water goes up and the Newton-meter goes down, and the amount that the Newton-meter goes down by is equal to the weight of the water that is here in this red block. So you've moved a certain amount of water out of the way, and the amount that you've moved out of the way is equal, so the amount that the Newton-meter goes down by is equal to the weight of this stuff here, because that's trying to push itself back there, and by trying to push itself back there, it pushes up on this block, because it says get out, I want to be there, and I have this much force, and this block's saying, well, I've got more force, so therefore I'm going to stay in the water. Okay, and we can work out how much that upthrust is providing as a force, because like I say, the upthrust is going to be equal to the weight of the water displaced, so we can say that is equal to the mass of the water times by gravity, because that's weight, and we know that the mass of the water is going to be equal to the volume times by the density times by gravity. So we know that if you want to work out what the upthrust on any given object is, it's the volume that is submerged times by the density of the fluid that it is in times by gravity. And if something wants to float, we know that, say if you've got a boat and it is on water like this, you've got your weight acting downwards and you've got your upthrust acting upwards. Well, if you want to float, then the weight must be greater than the upthrust. Nope, wrong way around. Upthrust must be greater than the weight. You know, the upthrust is equal to the volume of the water displaced times by the density of the water times by gravity. The volume of the water displaced is just how much is beneath the water. So let's say it's that bit there. Okay, and that must be greater than the mass of the boat times by gravity. You can see that the two g's cancel out, so what we're saying is, and you know what the mass, you know that the mass of the boat is going to, so that means that v, so at the point where it's just about to sink, we're not quite going to sink, these are going to be equal to each other, so you'd say the volume of this water that's displaced times by the density of the liquid, if that equals the volume of the object times by the density of the object, so that's of the fluid, that's the volume of the fluid, that's of the object, that's of the object. If those two are equal, then it would just stay afloat. If the density of the water is less than the density of the object, it will sink.